Hi, and welcome to Mplus Workshop 3. This is Janice Cookin. This week we will be going over regression options in Mplus. During every workshop, we build upon what we discussed previously. So far, we've talked about how to access Mplus on the remote desktop. We've run models reflecting commands in the Mplus syntax toolkit, and I pointed out some of the features of Mplus that are unique and could be overlooked. This week, I will provide examples of a lot of types of regression models. None of these will be multivariate, meaning more than one dependent variable, and we're also not going to be including simultaneous equations or complex or multi-level data. Those will be addressed in future workshops. But for today, we're going to look at the features that the regression command can offer when combined with features in some of the other commands to address many types of data and problems. Here are the examples that we're going to be working on in this workshop. I have 4 demos. One of them will address linear regression with continuous outcomes and also a quadratic regression with a continuous outcome variable. One will be on a logistic regression where the outcome variable is dichotomous. 2 will provide extensions of logistic regressions, including model fit. And then the last one will be a quick look at a multinomial regression. These are the resources I'm using this week. The Osborne website might be something I haven't shared with you yet, but that provides some good information on logistic regression. Many statistical techniques assume a normally distributed dependent variable, but normality is often violated, and that can result in biased results and incorrect conclusions. Robust options are available to researchers, but choosing the correct approach depends upon the distribution of the data and how well the technique aligns with study inferences and research questions. Recall that our variables may be nominal, ordinal, interval, or ratio. We need ordinal, interval, or ratio level in order for a variable to be considered continuous. Now, you might argue with me and say ordinal is definitely not continuous, and I would agree with you there. But researchers in methodology have identified some cases where ordinal, especially if it's 5 or more categories, can be used as continuous. Let me share some of this with you. All right, nominal conveys a name or label only. Examples include color, sex, and city. Those are things that you might see as a nominal variable. Ordinal, the scale has a definite order to it, where 1 is greater than 0, 2 is greater than 1, etc. So examples are Likert scales. Now this is the publication, Remtula, Rousseau, Liard, and Savelaye. I think I probably mispronounced that. But they did some research and identified some situations where if the Likert scale has 5 or more classifications, it might be able to be represented as continuous. I strongly recommend you take a look at that, and that might really support some of the work that you want to do. The other 2 classifications are interval, where there are numeric scales, or the differences between the points on the scale are equal and meaningful. So temperature is a good example of that. And then ratio scales are my favorite because they're continuous and they have a real 0. They're numeric, and the 0 represents an absolute 0. So a good example of what's not ratio is temperature, because 0 represents a particular, very cold place on the scale, cold temperature, but it doesn't represent the absence of temperature. Now, we have other problems other than measurement level: skewness, kurtosis, ceiling or floor effects, inflated data, discrete data, including count data, dichotomous data, ordinal and nominal data. Some statistical methods suggest transformations such as squaring, the Box-Cox transformation, or taking a logarithm. These can result in very large dramatic changes to the metric, and some classical textbooks, like Tabachnik and Fidel, discourage changing the metric of the outcome measure because this often results in problems with interpretations and comparability across studies. So Mplus has a variety of features that support regression analysis for your data, even if your data and your dependent variable is not normally distributed. Our discussion today will start with the assumption of continuous, but we will look at others as well. Here are the data sets for this week. We're going to be using this NELS Mplus, and it's a subset of the NELS data set from the IES. We're going to be working on graduation, SES, achievement scores, and sex. And then the Mplus is a subset of NELS, and it contains variables representing levels of usage of marijuana from none to frequent. Now, here are some examples of data that we're actually not going to cover this week, but they're important to know about. There's censored data, censored inflated, probit models, count data, and zero inflated Poisson or negative binomial. And I guess there's too many different examples for us to go through in this workshop. So my recommendation is to take a look at these. They download very easily from the Mplus website, and I'm going to actually demonstrate that a little later. But it's very important to know your data, to know how to represent it in syntax, and know how to interpret the results. Here are some helpful hints. Chapter 3 provides examples of regression models using many different types of data. And very important to know your data. Many times problems can be avoided by visual inspection. And always check the assumptions of multiple linear regression. Remember, the assumptions are a linear relationship between the outcome and the predictors. Variables should be multivariate, normally distributed. Residuals should be normally distributed with constant variance, and that's that homoscedasticity assumption, and they should be uncorrelated, and there should be no multicollinearity among the independent variables. One of the questions I often get is, do I write syntax? And the answer is no. I actually copy and paste. So I start with, the sample syntax files, the INP files that I've shared with you, and then I say, oh yeah, this is a linear regression, so I'm going to start with that, and that helps. Are you interested in multiple group analysis? If you could send me your research problem or a specific type of analysis, I can tailor the approach to the needs of the group. There are many different approaches to multiple group analysis, and many of them test for different degrees of multiple measurement invariance. I'm not sure if that's what you're looking for or not, so just let me know. Again, please contact me if you need support, and I'm also available by appointment. I realize that I am not going to be in SL 334 at those times, so pretty much I'm available by appointment. All right, thank you for your attention. Now it's time for us to run some Mplus.